Okay, so now that I've talked about what a catalytic converter is and why we have them, let's talk about why I removed it from my car. And my car is a 2009 Toyota Sienna. It's got 180,000 miles, so it's quite a lot. And it overheated a little bit. Every time I used the car for an extended period of time and I sat in traffic, the fan doesn't turn on when it should, around 200 Fahrenheit, which is less than 100 degrees Celsius, the boiling point of water. The fan should turn on low setting and then on high setting if it gets too hot. I think either the module or the sensor is not reading the temperature correctly, but the point is the fan doesn't turn on until it's actually really hot. And I had a problem with that car. I didn't want to spend any money on it because I'm a little bit cheap. So I tried to figure out ways in order to like make the engine not hot. I was just running the heater on for some time. Then I think I removed the thermostat from the thermostat housing. That helped a little bit. It didn't help that much though, because again, still when it got up to temperature, everything, the fan just didn't turn on and it started to getting a little bit hot. So the last option I did, well, not the last option I had, it's just the last thing I did was remove the catalytic converters. It actually worked quite great. I didn't expect, because if you see this on the inside, like my engine was not running rich or anything. Like this is clear all the way through. There's no excessive amount of black material. Like honestly, they're in perfectly good condition. But catalytics have to be hot in order to work. So this car has 3 of them, has 2 right next to the banks because it's a V6 engine, and then it has one bigger one for the rest of the exhaust part. And I removed all 3 of them, and since then the fan still doesn't turn on. But with the removal of the thermostat and the removal of the catalytic, even the fan not turning on, as soon as I move a little bit, it's fine. Like it has enough cooling on itself to like not overheat. One thing that I should mention though is that I also removed the condenser for the air conditioner. So if I have to run the AC, which is going to be relevant of the summer, it is going to overheat again. But I have a different solution to that. It's going to be on a different video. But yeah, that's one of the reasons I removed my catalytic converter. Now, talking about removal of catalytic converters, let's talk about more of the why people want to remove the catalytic converters. Because I'm one of them too. The heat was not the only reason I removed it. The second one was the sound. I like how cars sound. I have to be honest though, V6 sounds to me sound kind of terrible. So I kept the silencer and the resonator on the car. It actually makes almost no sound. Like the sound didn't increase at all, which is quite good. Like this is my car that I use almost every day. I didn't want to have some obnoxious sound, and it's completely fine. Like just without the catalytic converters. But if you go for special exhaust that don't have a catalytic converter on the car, for sound or whatever reason you have.
I'm not leaving.
Oh, you're not leaving? But okay, going back to that, if you choose to put a catalytic converter less exhaust system on your car, every car since I think it's 1996, it has to have a computer monitor that checks every major system on the car. So every major system would be like fuel injection, the fuel tank, the airflow before the engine, the exhaust flow outside of the engine, the emission part of the engine, which is the catalytic and the O2 sensors. What other systems does it have? I don't remember, but there's quite a few of them. And every car since 1996 has it. If you remove the catalytic converter on a car, you're gonna run into 3 problems exactly. Well, not exactly, but let's start. One problem is gonna be the emissions part. So cars have 2 oxygen sensors on the exhaust. They have one close to the exhaust manifold, and it looks at the air fuel ratio, how much oxygen you're having left over right after the combustion cycle. And then you have the catalytic converter, and then you have another oxygen sensor which measures the difference from before the catalytic converter and after the catalytic converter. So because you don't have a catalytic converter in the middle, the reading is going to be wrong. So the monitor that checks the efficiency of the catalytic converter is going to be off, and you're going to have a problem with that. The second problem that you're going to have is that if it has measuring of temperature too, you're going to get a wrong reading of the readiness of the sensors and the entire. So one thing is catalytic efficiency, like how well the catalytic converter is performing, and one problem different is that the sensors are always gonna be on a state where it says to the car that is not getting ready. The catalytic is not on a ready state to do its job. So if it measures temperature, it's gonna measure that the temperature is just not there for the catalytic converter to work. One example I think is gonna be the Toyota Prius. The new Prius, on the catalytic converter, it has cooling, and there's a bunch of cooling lights that go exactly where the catalytic converter is, and that is because the catalytic converter has to be at a temperature, at a precise range of temperature in order to work, and you are gonna mess with that if the entire piece is just missing from there. So the readiness state of the temperature, the readiness state of the efficiency is gonna be off, and lastly is gonna be the EGR. If the car has EGR somehow built into the manifold close to where the catalytic converter is, and the manifold that you install doesn't have it, or you just cut the catalytic converter like I did and you had to cut the EGR too, you're gonna have a problem with the EGR part of the system, because if you completely delete it, it's just not gonna be there. The valve is not gonna measure the correct flow or the correct pressure that it should have. So those are problems that can arise. What this is gonna cause is that you're gonna get the check engine light on, and if wherever you live has smoke testing for inspections, then that's going to be a problem too. Now let's first do the check engine light. If you live on a place where the only worry that you need to have is having the check engine light, as long as you can find some way to cheat the sensors, because there are ways to do it. If you can find a way to cheat the sensors just enough so that the monitors can get ready, then you're gonna pass inspection no problem, because these sensors take a while to like get the full readings. Like it works on average. It's not instantaneous reading and then if it's off it throws the check engine light. No, it works in average, because the engine at 2000 revs and at 5000 revs is going to perform very differently, and the emissions are completely different. So the computer just takes average, sums it up, and then you get the reading from there with the average. As long as you can cheat a little bit so that the average is within range in order to pass inspection, is going to be fine. Let me give you some solutions. Some solutions is, for example, they have spacers for the O2 sensor that allow much less air to hit directly on the sensor, and that is one way to do it. Also, if you really want to get into like the weeds, maybe because you cut off the EGR and that could be a problem, you can put resistors onto the sensors, or the it has to be the actual cables though. You can put resistors onto some sensors only in order to get an average voltage that is within the range of what the car is supposed to read. Now, this doesn't work on every car and on every sensor, because some sensors do have like a baseline reading, which if it's not there, it is gonna mark it as the sensor not working properly. So let me give you an example. The battery is 12 volts. Let's say the average reading for the sensor on like a span of 60 seconds has to be 3.5 volts, let's say. So then you do the math, you put a resistor that with the 12 volts battery, it is gonna output you 3.5 volts, or maybe 3.6 volts, whatever, doesn't matter. When you turn the ignition key on, the computer, if the sensor is not connected with the baseline of the 12 volts, and first the computer sends 5 volts into the sensor just to get a proper reading that it gets the 5 volts back, or maybe 0 volts, or maybe 1.5 volts, because if it doesn't send the 12 volts and it instead sends 6, then maybe it gets back 1.7 at first, or 1.6, something like that. You get what I mean? Like if it has a first checkup different voltage and the car doesn't read it, it can give you a check engine light marking that the sensor is not working properly. That's if you go with the resistor route. If you put the spacers, for example, that's not really the case. But that's an example of how you can cheat the system. Now, if you have smog testing on your state, it becomes quite a bit harder to cheat it, because they actually put a probe on your exhaust and measure directly how much emissions you're doing, both particulate matter, which is smoke, and the harmful emissions that they don't want from cars coming out. Now, why is it harder is because they're not relying on the sensors that you manipulated on your car in order to get a proper reading. They're actually reading it directly from the equipment that they have. The only way that I have seen that people cheat this is that they actually have to put a valved exhaust system. That is, they open a valve and you have direct exhaust manifold, and then they can close a valve in order to have a small, at least like a very small catalytic converter in order to pass the smoke test. So it has to be like, you have to have a catalytic converter. Doesn't have to be the original size, doesn't have to be very efficient at all. It just really has to be good enough in order to pass inspections, which you only use it with a valve in order to do that. That is the other option that I have seen. Now, that goes for removing your catalytic converter. What if it just fails? For example, that's something that happens quite often. Well, if it fails, it can be for several reasons. I am gonna assume that you know that your catalytic converter is bad. Well, if you know for a fact that your catalytic converter is bad, really, you don't need to change it. Catalytic converters should not affect the performance of the engine, and most of the time they're never going to affect the performance of the engine, especially on a stock car. Like, I'm not talking about modified ones. On a stock car, they're really not meant to affect the engine on any way, shape, or form, even if they don't work properly. But people have problems trying to pass inspection, which is a problem. Now, what you can do on that situation is just have the check engine light cleared, and you can try to drive just enough to pass the inspection before the check engine light comes on, and you cannot pass inspection. If you have a bad catalytic converter and they smoke test, well, that one is a little bit harder. They make chemicals that are supposed to clean the catalytic converter. Do they work or no? It's up for debate. They do work, but it really depends on the situation and how bad your catalytic converter is. But what I can tell you, one thing though, is that if you really don't want to fix the car, the catalytic is bad, and you really want to pass the inspection, what you can do is run the engine really hot. Hot engines burn fuel more efficiently. They damage the engine, yes, but they make less smoke emissions, maybe more nitrous emissions, but smoke particulate from the soot of the exhaust, they get reduced by quite a lot. So you can try going on the highway or revving the engine really hard for a couple of minutes, maybe like 10-15 minutes, and make sure that when you get to the place you don't shut the engine off, and maybe keep it even revved a little bit so that everything is as hot as it can get, so that it can burn all the particulates of fuel that you have. That is one option. So that, I think that covers everything. Like why you and the last thing I wanted to cover, one part of the industry where this is a big problem, more even than on cars, it's on diesel trucks. Since I think it's 2008, every diesel car needed to have a proper emission reduction system, and almost every company by now has settled with diesel fluid, with selective catalytic reduction with the urea gas. They settle on this because, again, the theory is very good. You convert almost all of the diesel emissions and the nitrous oxide emissions into water, carbon dioxide, and I think it's pure nitrogen, if I remember correctly. They get rid of almost all nitrous oxide emissions, in theory. And because it performs really good, almost every company now uses that system. Now the problem is that diesel engines today, if you buy a diesel truck, most problems that you're gonna have are with all the sensors and all the extra equipment that was attached to this diesel engine. So in the olden days, one of the reasons you wanted to get diesel is because maybe the maintenance is a little bit more manageable, maybe the performance for you is better. But it is true when people say that the selective catalytic reduction has ruined diesel engines, and many people remove them completely, or they buy older engines from older trucks and put them on the car in order to have not these problems. It is so bad to the point where like people have actually measured like 5-10 miles per gallon difference from having the system and completely removing it from the car. So it is quite relevant. Like it is something that people consider a lot when they have a diesel truck. The problems that they have are a little bit different with the cars though, because on cars there is no, it's not as extensive as with the diesel ones. Like with the diesel ones, it's insane. Like if you run out of fluid, the engine has to like shut off automatically, like software locking the engine until you take it to the dealer to get it fixed. Also, if it doesn't reach temperature, operating temperature within a certain amount of time, you're gonna have problems too. What other problems they have? Mostly it's those. Mostly it's the temperature that they have, and the fluid, and also the EGR, because one of the problems that modern diesel engines have is that they run a little bit colder inside the engine, or they run a little bit rich fuel in order to reduce the nitrous oxide emissions, especially when the engine is cold. And what happens with that is that diesel engines create a lot of soot when it's running rich, and because of the EGR, it completely, because there's no, because it's direct injection and you have no fuel on the outside and nothing to clean it with, the intake can sometimes get extremely dirty and things can get clogged, and you're gonna also get problems with the engine. But it's not really the engine, it's the things that the EGR is causing. So those are some of the problems that you can have. That mostly covers like trucks and cars, which is what I want to talk about. If you want to remove your catalytic converter, you can. It's just mostly you're gonna have to deal with some problems, let's say.